Hi everyone, I'm going to discuss solving system of linear equations, this time using the Cramer's rule. Now with this method, we're going to define what is the determinant of a 2 by 2 matrix. So the determinant of the matrix defined by the elements A, B, C, D to be a real number of AD minus BC, we write the determinant equal to A times D minus B times C. Now, in relation to the solution to this system, A sub 1x plus B sub 1y equals C sub 1 and A sub 2x plus B sub 2y equals C sub 2. So, calculating the x coordinate is done by dividing d sub x by the determinant, and the y coordinate is done by dividing d sub y all over the determinant, where d again is equal to this formula, d sub x here and d sub y. So the manner how we calculate for D is the same way also how we calculate D sub X and D sub Y here. So this is like we get the difference on the cross product of the two. So for D sub X, this is C sub 1 times B sub 2 minus B sub 1 times C sub 2, as well as with D sub Y, this is equal to A sub 1 times C sub 2 minus C sub 1 times A sub 2. Now, D must not be equal to 0, otherwise we'll come up with an undefined value. So let's solve for the solution of each system using the Cramer's rule, where x equals d over x all over d and y equals d sub y all over d. So where d sub x and d sub y are equal to this equations. So let's work on number one. So the first thing that we're going to do is to work on each value of d sub x, and d sub y. So for d, we have d equals, so a sub 1 here is the coefficient of the x of the first equation. So this is 2, while a sub 2 is 1, and then b sub 1 is negative 1, and then b sub 2 is 1. So we'll get the difference between the cross product. So we have 2 times 1 here minus negative 1 times 1. So this is 2 minus negative 1, which is equal to 3. And then we'll work on the sub x. And d sub x equals c sub 1. So we have negative 4. And then c sub 2 is 1. B sub 1 is negative 1. And then b sub 2 is 1. So d sub x equals negative 4 times 1 minus negative 1 times 1. So this is negative 4 plus 1. So this is negative 3. And then we'll work on d sub y. And d sub y equals, so we have a sub 1 again and a sub 2. We have 2, 1 respectively. C sub 1, C sub 2, we have negative 4, 1 respectively. So d sub y equals the difference between between the product of 2 and 2 and 1 minus the product of negative 4 and 1. So we have 2 minus negative 4. So this is 2 plus 4. So we have 6. So we can solve now for x, and x is d sub x all over d. So we have d sub x equals negative 3 all over 3. So this gives us negative 1, while our y is d sub y all over d. So our d sub y is 6 all over 3. So we have 2. So the solution set, or rather the solution for this system is at negative 1, 2. So we have to verify if really that is the solution. So the solution should satisfy both equations. So substituting negative 1, 2 to the first equation, we have 2 times negative 1 minus 2 equals negative 4. So this is negative 4 equals negative 4. How about the second equation? So we have negative 1 plus 2 equals 1. So therefore 1 equals 1. So this satisfies both equations. So this must be the solution. Next is working on the solution of the system here. Again, we'll solve for D. So D, so we have A sub 1 equals 2, A sub 2 equals 1, and then B sub 1 negative 1, B sub 2 3. So working on D, so this is 2 times 3 minus negative 1 times 1. So this is 6 minus negative 1. So this is 6 plus 1. So this gives us 7. For D sub X, so we have C sub 1, C sub 2. So we have 4, 9 here respectively. And then B sub 1, B sub 2. So negative 1, 3. So we have 4 times 3 minus the product of negative 1 and 9. So this is 12 minus negative 9. So this gives us 21. And for D sub y, so D sub y, A sub 1, A sub 2, so we have 2 and 1 respectively. And the C sub 1, C sub 2, we have 4, 9 respectively. And then working on the difference between their cross product. So this is 2 times 9 minus 4 times 1. So this is 18 minus, so this is 18 minus 4, and this gives us 14. So solving for x, so x is d sub x all over d. So d sub x is 21 all over 7. So this is 3. While y equals d sub y all over d. So we have 14 over 7. This gives us 2. So the solution is 3, 2. So we have to verify if 3, 2 satisfies both equations. So substitute 3 and 2 to the x and y of both equations. So we have 2 times 3 minus 2 equals 4. So this is 6 minus 2. So definitely 4 equals 4. For the second equation, this is 3 plus 3 times 2 equals 9. So this is 3 plus 6 equals 9. So this gives us 9 equals 9. So really, this is the solution for the second system. Next, number 3. So we'll solve for the determinant. So we have a sub 1 and a sub 2, 1, 1 respectively. And then b sub 1, b sub 2, negative 1, 1. Solving for d, so this is 1 times 1 minus negative 1 times 1. So we have 1 minus negative 1. So this gives us 2. While our d sub x is c1, c2. So we have negative 6 and 8. And then b1, b2, negative 1, 1. So we have negative 6 times 1 minus product of negative 1 and 8. So this is negative 6 minus negative 8. So this is negative 6 plus 8. So negative 6 plus 8 equals 2. Okay, so for d sub y, we have a sub 1, a sub 2. So we have 1, 1. And then c sub 1, c sub 2, we have negative 6, 8. So this is 1 times 8 minus the product of negative 6 and 1. So this is 8 minus negative 6. And this gives us 8 plus 6. So we have 14. So solving for x is working on d sub x over d. And d sub x is 2 while d is 2. So x is 1. While y is dy all over d. And d sub y is 14 divided by d, which is 2. This gives us 7. So the solution here is 1, 7. So we have to check if 1, 7 satisfies both equations. So with equation 1, we have 1 minus 7 equals negative 6. So negative 6 equals negative 6. And then we have 1 plus 7 equals 8. So we have 8 equals 8. So 1, 7 satisfies both equation. Therefore, 1, 7 is the solution for this system. So for number 4, solving for the determinant. So this is a sub 1, a sub 2. So we have 2, 5 here, b sub 1, b sub 2. We have 1 and 2 respectively. So this is equal to 2 times 2 minus 1 times 5. And this is equal to 4 minus 5. So this gives us negative 1. While d sub x is c1, c2. So we have 7, 16 respectively. And then b1, b2, we have 1 and 2 respectively. And then 7 times 2 minus 1 times 16. Okay? So this is 14 minus 16. So this is negative 2. And d sub y is a sub 1, a sub 2. So we have 2, 5. And then C1, C2. So we have 7, 16. So we have 2 times 16 minus 7 times 5. So we have 32 minus 35. So we have negative 3 here. So x is d sub x over d. So we have negative 2 over negative 1. So this is 2. While y is dy over d. So this is negative 3 over negative 1. So this gives us 3. So the solution here is 2, 3. And we have to check if 2, 3 satisfies both equation. So we have 2 times 2 plus 3. Is it equal to 7? So is 4 plus 3 equals 7. So 7 equals 7. For the second equation, this is 5 times 2 plus 2 times 3 equals 16. So this is 10 plus 6 equals 16. So 16 equals 16. So I hope you are able to understand how to solve for the system using the Cramer's rule. So I was able to discuss 4 methods in solving for the systems of linear equations into variables. So we have graphing, elimination, substitution, and this Cramer's rule. So next meeting, I'll be discussing solving systems of linear equations in 3 variables. So that's it for now.